Hi, I'm Kirandeep from WeDiscover. We're a paid search and marketing tech agency, and we've created this video to share our new experimentation studio, which can support you in developing a robust testing process. We believe testing and experimentation should be at the heart of running efficient and scalable paid search. Doing this well means not just simply concluding a test when a variant looks to have outperformed another across a single metric, but ensuring differences are statistically significant and have statistical power before making any final decisions. Because we do this so regularly, we have built a tool to do this across a wide range of scenarios, and we're releasing it as an open source Google Ads script and Google Sheets report template to help you run more effective tests and alert you when they have concluded. With our script and sheet, you can set up and evaluate a traditional A/B test with a control and a variant, or expanded test with up to 6 variants, a test using drafts and experiments in Google Ads, or a test using the pre-post methodology. Tests can be configured using labels or including tags and campaign names. In this video, we're going to walk through the setup and evaluation of a number of these tests to demonstrate the scale of its usability and make it easier for you to measure your next test more effectively. When you open the sheet, a range of tabs will be visible. The first of these is the Test Summary tab. When set up, this summarizes where a test has reached a significant outcome across a range of key Google Ads metrics. The confidence level, 1 - alpha, and power, 1 - beta, of your test can be adjusted in the controls section at the top of the report. These are explained in more detail later, but will help you ensure you draw trustworthy conclusions. The objective metrics that you can evaluate a test against are split into rates, such as click-through rate, CTR, conversion rate, CVR, and conversions per impression, CPI, as well as volume metrics like cost, clicks, and conversions. This table is purely intended to give you a summary for a given test. We're now looking at the Drill Down tab for all variants. Here we can dive into more detail on specific tests and display visualizations that can make breaking down your results and understanding the different performance across variants even easier. There is one tab for comparing all variants in a given test, and a separate tab for comparing 2 variants in a traditional A/B style. The first table shows a summary of all of the key metrics by each variant. Lower down, you can compare the distribution of your objective metric and understand if there are significant differences and whether these have statistical power. In this section, you'll be able to see a list of your variant alongside a performance overview with key takeaway boxes that highlight when one is confirmed as being significantly higher or lower than all other variants. We'll be diving into much more detail on the meanings and value of all of these metrics in the Understanding Your Results section, but all statistical terminology also comes with embedded notes when hovering over the respective cells. Finally, there's a section at the bottom of the page which will show graphical representations of your objective metric across each variant, which can be great to bring the performance of a test over time to life. The Test Configurator sheet is where you can simply set up your test. Once added, information from there will pull into a specific registry sheet depending on the type of test setup. More on this in the next section. There is also a specific glossary tab in the sheet, which provides a list of terms in each section alongside the definitions. These notes, aimed at those less familiar with these types of calculations, but also useful as a refresher for those who are, provide greater context to the results displayed. We're now going to walk through how to set up your first test with this tool. First, make a copy of the Google Sheet template you found linked in the article on the WeDiscover website. Secondly, open up the script linked in the article and available on GitHub. Finally, open the Google Ads account that your test is running in or going to run in. It can be an MCC or single account. We'll come back to this later. We're now going to walk through how to set up the script. In your Google Ads account, click on the Tools icon at the top of the screen. In the drop-down that then opens up, under Bulk Actions, select Scripts. Click on the blue plus icon to create a new script, and then copy and paste our script from GitHub. Be sure to delete anything that is already in the box for the script insertion in Google Ads first, then copy and paste the full script from GitHub into Google Ads. You may want to edit the script name at the top, as this will allow you to easily differentiate between different scripts you enter. The script is broken down into sections, with the orange text providing an explanation of what each section does. The variable labelled edit me indicates that you will need to supply information there in order for it to work properly. You need to supply your G-Sheet ID to allow the script to collect information on the test configurations you set up earlier. This ID can be found in the URL of your G-Sheet. It is the value between D and edit. Authorize the script when prompted to allow it the appropriate access and then set it to run. You can set this to run at any desired frequency. Our recommendation is once daily, usually in the morning. The script will run and iterate through all tests configured in the Google Sheet and export out aggregated data to be used in the analysis. The majority of tests supported by this tool use labels for identifying variants, with the only exception being drafts and experiments. Labels applied at an ad group, or campaign level can be used for comparing different entities, for example in an ad copy test, or the same entities over different time periods, as in a pre-post test. Skip to the section that is relevant for you to get a better understanding of where to apply these in Google Ads, depending on the type of test you are configuring. You can also find a help page linked in the article that assists with how to set up labels in your account. Label tests are the first test type we're going to explore. These are arguably the most flexible type of test supported by the tool and effectively allow you to create tests by applying labels to ads, ad groups, or campaigns. Use the test configurator sheet to set up a label test. You can set the name of your test, start date, entity type, and number of variants. The labels generated will contain both an identifier for a test and for a specific variant. Any entities that you apply these labels to within your Google Ads account will be included in the respective variant for the respective test. One of the most common use cases we have internally for this type of test is for ad copy. We often set up tests where we have 3 types of ad copy running across multiple ad groups and campaigns, and use this tool to evaluate when one is performing significantly better or worse than the others. In the case a variant performs worse than all of the others, we replace it with an ad we might expect to perform better. With this testing style, it is possible for variants to receive very different levels of exposure, so it is important to set up your test in a way where you can expect it to be fair. We cover common pitfalls, evaluating fairness, interpreting results, and other types of tests you can implement with labels in the accompanying article. The other type of test that you can set up by applying labels in your account is a pre-post test. Pre-post testing is traditionally used when it's not possible to test your variants concurrently. For example, if you're changing a feature of your product or it is not possible to create a traffic split. Use the test configurator sheet to set up a pre-post test. You can set the name of your test, start date, and end date for each period, and the entity type that you apply labels to. We generally favour this testing type less than concurrent testing using label or drafts and experiments, but sometimes it is necessary. In an ideal world, these types of tests will run for similar timeframes across both pre- and post-testing periods. The same evaluation sheet, showing the same metrics and breakdowns, is used for this test type as with the labels test type. There are several things that you should consider when setting up a pre-post test to ensure it's as fair as it can be, and this, alongside interpreting results, are explored in the accompanying article. One of the key benefits of this tool is the ability to simultaneously run label-based tests as outlined in the previous section, alongside other tests like drafts and experiments. One notable difference between how drafts and experiments works within the tool compared to the previous test types lies in their setup within Google Ads, where the experiment campaign name is edited instead. To set up a drafts and experiments test, in the test configurator sheet, select experiment as the test type, then set your start date. In the Experiments Registry tab, copy the experiment suffix and append this to the end of your campaign experiment name set up in Google Ads. Note here that if you add this to any other part of the campaign name, the setup will not work. You do not need to edit the original campaign name involved in the experiment. Where possible, we advise using drafts and experiments tests, as these are arguably the fairest in terms of setup, as it allows randomization at the cookie or impression level. We quite often use these kinds of tests when experimenting with location targeting. We cover interpreting results of drafts and experiments tests and some examples of where we find them useful in the accompanying article on the WeDiscover website. As a paid search practitioner, you are likely familiar with the majority of metrics in this sheet. However, there are two key metrics in significance testing that are worth explaining. These are the confidence level and the power achieved. This particular area of stats is about the uncertainty around your metrics and your ability to extrapolate your conclusions to the wider population. In short, there is a measurable difference between your variance for a particular objective metric, and you need to know whether this difference was due to randomness or because of an inherent difference in performance. The confidence level indicates how certain you can be that your result didn't occur by chance. For example, if your test is significant at 90%, there is a 10% chance that your result happened purely by chance. Provided you have the scale to do so, we would recommend aiming for a 95 or 99% confidence level. Power refers to the probability your result is a true positive, and therefore that you can trust a statistically significant result. To expand on this, your statistical test can return a significant outcome. However, there is still a possibility that this result is a false positive. Power is the probability that your significant result did in fact occur. The minimum acceptable level of power in research is 80%, and power is increased by increasing the number of samples for a given set of variants. There is a lot more to say on this topic of interpreting results, and we explore this in depth in the accompanying article alongside some worked examples of experimental analysis.